Good day everyone, and welcome to another video of Mr. Fankedu Solutions. I'm going to be looking at the topic determinant of matrices. This is a very crucial part in our discussion of matrix. Now, for us to understand determinants, we have to go gradually. So we're going to start from the determinant of a 2x2 matrix. I think if we explained the various order and size of a matrix, and this 2x2 matrix is a square matrix. Basically, we can only find determinants for square matrices. Please, if you're having difficulty with understanding what I just said, please do well to watch our first video on matrices and calculation of matrices, the second video, and which will put the link in the video description, and I guess you'll be able to understand how this all started. Now, determinant of a 2x2 matrix, when you have a 2x2 matrix, as in the case of A here, which is A, B, C, D, basically determinant of A will be A times D minus B times C. So 2x2 matrices are very easy to solve. It becomes very easy to solve if it's a 2x2 matrix. Now let us see a question on a 2x2 matrix. You can see here we have 1, 2, 3, 4 is the matrix A, and we're asked to get the 2x2 matrix. What do we do? All we have to do is to do 1 times 4, which we have done, which gives us 4, and 2 times 3 gives us 6, and 4 minus 6 gives us minus 2. So that's basically how to solve. It doesn't get harder than that. That's the general way of solving 2x2 matrices. Also, we can now move straight to 3x3 matrix. As you can see, if we have matrix A, B, C, D, E, F, G, H, I, which is a 3x3 matrix, you can see I assigned signs to the top, which is the minus, plus, minus sign. Although I think it should have been plus, minus, plus. Sorry, please pardon the error there. It should be plus, minus, plus. So what happens is the determinant. To get determinant of A, we take the determinant of the matrix A. So we start with small letter A, the first element there. We eliminate all the rows and the columns. So with A, like on A, the row is B and C, so you eliminate that, and the column D and G, eliminate that, and what remains is E, F, H, I. So you can see A, and then we'll find the determinant of E, F, H, I. Also, you do the same for B, but like I told you, it's plus, minus, plus, so B will take a negative sign, so it will be minus B dot determinant of, when you eliminate all the rows in B, that's A and C, and eliminate all the columns in B, which is E and H, all you have is D, F, and G, I remaining. And then when you get to C, eliminate all the rows in column C, which is A, B, and all the columns, which is F, I. Then you have D, E, G, H. So multiplying those individual elements with the determinant of what remains. Okay, usually what remains is really called the minor. So multiplying the element and its minor will give you the determinant that you are looking for. So basically, let's see how we can apply that in a question. So we have find the determinant of this. So how do we go about it? First, start with the first number there, 1. We eliminate each row, 3 and minus 2, 0, 4. All you have is 5, 1, minus 1, 2. And for 3, you eliminate 1 minus 2, 5 minus 1. You have 0, 1, 4. I think should be, that's an error, should be just 2 for root minus 2. And then also lastly, and remember what I said is plus, minus, plus. So 3 will take the minus sign, and also lastly minus 2 will take the positive sign. So minus 2, 0, you eliminate 1, 3, 1, 2. You have 0, 5, 4, and minus 1. So if you multiply it out, you're going to have this, and at the end of the day you get an answer as 63. So I believe it is actually very simple, because 5 times, to get determinant 5 times 2 you get 10, minus 1 times 1 you get plus 1, which is 11, times 1 gives you 11. So you have minus 3, then you have 0 times minus 2 is 0, 4 times 1 4, so 0 minus 4 gives you minus 4, minus 3 times minus 4 gives you plus 12, and you have 0 times minus 1 0, 4 times 5 times 0 minus 20 is minus 20, minus 20 times minus 2 gives you plus 40. So adding together you have 63. Now we can move into minor and cofactors, because I'm sure we all saw a lot of things. Then you will probably be wondering what the heck just happened. okay, basically, like we analyze, if you have a matrix A1 1, A1 2, A1 3, A2 1, A2 2, A3 2 3, if you look at the diagram below, you see that if you get A1 1, the minus of A1 1 is A2 2, A2 3, and A3 2, which is what we're doing in the 3 by 3 matrix. Just eliminate the row of A in A1 1 and the column in A1 1. Then what remains gives you the minor of A1 1. So basically, to solve the 3 by 3 matrix, we're taking minor of A1 1, A1 2, and A1 3 to solve the determinant of a 3 by 3 matrix. Okay, so that is basically the principles of minor. Now you can get the minor of any element. Now what is now cofactor? So basically, we have said that the minor is basically eliminating those elements. Now what's cofactor? Cofactor involves when you eliminate, there's a sign assigned to each and every one of these factors. Like you can see in the small diagram there, the first guy takes plus, second guy takes minus, third guy takes plus. When you go to the second row, you have minus, plus, minus, and the last row you have plus, minus, plus. Then we can see this quite clearly here. So if you are told to get the minor of A1 1, you can see just eliminate 1 2 2 1, you get the minor. So getting minor is really easy. So let's look at M2 3. The minor eliminates the row. You have M1 M2 sorry, mistake. If you want to get the minor of A2 3, which is M2 3, the minor of A2 3 is M2 3. So if you want to get the minor, you go to A2 3, eliminate the row, you eliminate A2 1 and A2 2, eliminate the column, eliminate A1 3 and A3 3, and what you're going to have is A1 1, A1 2, A3 1, A3 2, which is what we have there. That is basically how to get minus. Now let's look at adjoint of a matrix. Now the adjoint of a matrix basically is the transpose of the matrix of cofactors. So basically of cofactors. Now note, I don't know if I stated this earlier, but the only difference between a minor and cofactor is that for minor it's just the number, then cofactor is when you add the sign, positive or negative, which I showed you is plus, minus, plus, minus, plus, minus, and plus, minus, plus. So basically follow the signs, it just follows each other, plus, minus, plus, minus, plus, minus, plus, minus. That's the way I try to use to remember it. So if you take them, so we can see that this guy A22, A23, A32, A33, you can do it somewhere beside you. You can see it is the minor of A11, so the sign is plus 2, so that makes it the cofactor. So the minor plus the sign it should take makes it a cofactor. So if you get the cofactor and you take the transpose of a cofactor, then you have an adjoint. So the transpose of any cofactor of all the elements, like cofactor mean if you have A11, A12, A13, A21, A22, A23, A31, A32, and A33, if you take the individual cofactors to one after the other and you form a matrix with it and you take the transpose, that gives you your adjoint. That makes us able to talk about inverse of a matrix. Now I believe that some of these things will become really clear in calculation class. Like you know, for those that have watched our first set of videos, we'll do a video, we have the calculation class. Okay, so we have 3 sets of videos: the video, the calculation class, and the do you know series. So these are the 3 series that we have, so you can follow each and every one of them. Expect we're going to try and be dropping at least the 3 of them in a week. It's not be really easy because of many things we do, but we'll try to always meet up. Now let's look at the inverse. For a matrix A, if you are trying the inverse, A inverse is basically one of the determinant of A multiplying it by the adjoint of A. So we know the adjoint. The adjoint is basically the transpose of cofactor matrix. So if you do if you divide all the values of the cofactor matrix by the determinant of A, you get the inverse of the matrix A. So we thank you for watching this video. Please do well to like, subscribe, share, and drop your comment. Please, I hope you really understood the important part, because basically the video was based on determinants, but I decided to include other things that determinants can help us solve, like the adjoint, the binomial, cofactors, and the likes. So, but in our conclusion class, we will solve a question that's going to encompass each and every one of them, so that we'll be able to follow up and we'll be able to understand. Thank you for watching, and please do well to subscribe. Please subscribe, please subscribe. Thank you.